The new stone is terrible. That's why. All right. So we're finally going past histology, and we're talking about some gross anatomical structures. We're talking about bones, which is, I know, what you all think of when we think of anatomy. You think of muscles and bones, but obviously it's more than that. But we're finally getting into that stereotypical muscles and bones. But when we talk about bones, we're going to get into the nitty-gritty of it, not just names of bones, and you will memorize every single name of every single bone in your body, minus the small sesamoid ones. But we are going to go over some major features of bones. Everything labeled here has a name. Like, this is the femur, but every single part of the femur has a name. We bother naming all these parts because they're important. They have, remember how structure relates to function? Just like this bottle opener corkscrew thing, every single thing on here has a name and a function. This opens bottles, this is for opening wine bottles, this is for cutting the wine thing on the top, I think. Yeah. Every single thing has a structure and function. The same is true for a bone. There are smooth parts, there are rough parts, there are rounded parts, there are notches, there are holes. And so we're going to go over those things. Long bones. Okay, so there are 4 basic shapes of bones, and I'm just going to briefly go over them. Long bones, as the name implies, are long. These slides are online, and they should be. It stops there. Sorry, they are online. Damn, I thought okay. Long bones are long. They undergo endochondral ossification. You find them typically on your appendages. So your fingers, your forearm, your humerus, your clavicle. Who's asking about the clavicle? Clavicle is a long bone. All these are examples of long bones. And they're longer because that means they can reach and have a longer area to pull. So if the muscle's attaching from our elbow to our wrist, that means when we pull, we're moving a greater distance. Long bones are great for mobility, which is why we find them on our appendages. When you look inside of a long bone, because it undergoes endochondral ossification, that means you've got compact bone on the edges, spongy bone in the middle, and you have cavities inside in the diaphysis and then marrow at the epiphyses. So we've gone over those different regions of the long bones already. But by being long, it has plenty of attachment, plenty of places of attachment for muscles, and that way you can move your appendages. Small bones or short bones are small. You typically find them at your wrist and your ankles, carpals and tarsals. Small bones are very the way that they're arranged is that they have compact bone towards the edges and spongy bone in the middle. There's no cavity like there is in a long bone, which means it lacks what kind of marrow? Yellow. So you have a lot of yellow marrow here. You don't really have that here. I mean, there will be fat in there, but it's not the same thing. By being small, that means it's easier to move across. It allows for gliding motions, high mobility. So you find this at wrists and ankles, carpals and tarsals. Yes? When you get a bone marrow transplant, where do you get it from? You typically get it from the femur or the hip, because the femur is really long bone, and it's in the hip area because that's where the epiphysis is. So yeah, it's typically in that area. Flat bones are flat, as the name implies. You typically find flat bones in the cranium. When I say cranium, I mean the large flat bones that are protecting your brain. Your facial bones are different. Flat bones are the ones over here. So the ones in the cranium, the flat bone of your coxal bone, the pelvis, so this flat wing here. What else? Oh yeah, the flat part of your scapula. Flat part of your scapula. Your ribs are also considered flat too. I know your ribs look long, but they're considered flat. Flat bones undergo intramembranous ossification. But when they're fully formed, you've got compact towards the edges, spongy bone in the middle. It's kind of like small, but flat. By being flat, it also has a lot of area for muscle attachment. You'll notice that you've got flat bones in the hips and you've got flat bones in the shoulders. These are good attachment points or anchoring points for your arms and your legs. So you need a lot of muscle attachment to help support your arms and legs. That's the benefit of having, also they're also good for protecting. So by having a flat curved area, it's protecting your brain, it's protecting your genital organs, it's protecting your thoracic cage, your heart and lungs. If it doesn't fit into one of these categories, it's going to be one of these other ones. This is a very specific type of bone. It's called a sutural bone. A sutural bone is a bone that's in between other bones on the skull. So here we have an actual human skull, I think. Maybe not, I don't know. Could be a mold. But you'll notice that in between the flat bones, like if this is one flat bone and then here's another flat bone, when these two bones fuse together, it's not always perfect. And sometimes you'll have this one spot in between these two larger flat bones where you need bone filled in. Remember, this is all by intramembranous ossification. So it's just you've got bone here, you've got bone here. They eventually come together, but then you have one area in the middle where there's nothing. You need to fill that in with bone. This joint here is called a suture, and if you need to fill bone in, that's a sutural bone. So it's a very small, irregular, jagged bone. It's different for everyone because the rate of our ossification is different. So it's just that tiny, tiny bone only found in the skull. It's very, very small. If you want to see this, I'll pass it on. That's a sutural bone. It's just to fill in the gaps of the skull. This next one is called pneumatized. The P is silent. You ever heard of the term pneumatic? If something's pneumatic, what are you using to lift something? Air, using air. So this is an air-filled bone. You only find this in your face. So this frontal bone and other bones that we'll name later, they have sinuses. They have air spaces within the bone. They're filled with air. The reason why we have sinuses, I know they get clogged a lot and can cause pain, but the reason when they're working properly is that they can help filter air, they can make air more humid, less dry, and they can heat air up because the air around us is typically dry, cold, and full of particles. We want to filter air before it gets to our lungs. By having sinuses, by increasing surface area, that allows for more opportunity to do that. So you only find pneumatized bones in this area of your face, the paranasal area. These categories, sometimes you can have overlap. Like this frontal bone is flat, but it's also pneumatized. A part of it's also pneumatized. So these categories, bones can fit across categories. The frontal bone is both flat and pneumatized. Another type of bone that's really small and sometimes irregular is called a sesamoid bone. This just means it's shaped like a sesame seed. Small, round, smooth on one side. The biggest one, the only sesamoid bone that I'll ask you to know and name is the patella. Your kneecap is a sesamoid bone. By being flat and smooth on the anterior edge, that allows the tendon and ligament that's going across it to easily move across. It acts like a pulley, so it's easy to move your leg, easier to move your foot. You have sesamoid bones not only at your knee, you have them in your knuckles, you have them in your toes. These ones are super small. We're not going to name them, so don't worry about them. But you also find them at those really movable joints. So that's sesamoid, shaped like a sesame seed. All right, last one, irregular. This is, if it doesn't fit into any of these categories, it's irregular. Your best examples of irregular bones are your facial bones and your vertebrae. Facial bones are shaped really funny, as we'll see. And your vertebrae have an interesting shape as well. With irregular bones, parts of it are made through endochondral ossification, parts of it are made through intramembranous. So let's say we want to form a vertebra. We've got parts of it forming like this, but then we need to fuse it together with other bone to form something like this. So it takes some time for it to fuse together. It doesn't necessarily form an irregular shape. So there's a lot of facial bones, vertebrae, and parts of your hip bones that are irregularly shaped. Those are all the bone shapes. I'm going to quickly go over these terms. I'm not going to go over every single term because the only way to get used to this is just to practice it. Me saying it out loud is not going to help you. But every bone has little protrusions or flat parts or something that, some interesting structure of the bone that gives it some kind of function. Bones will come together at a certain point. That's called an articulation. The fancy word for joint is articulation. You can see that this bone is a little flatter and this bone is a little rounder. By this one being flat and shallow, by this being round, this allows the bone to move. Any point where bones meet, that's an articulation. And there are different terms for different types of articulations. So if you see these terms, it's implying a place where bones are meeting. If something's poking out of the bone, that's an extension or a projection. And if you have something poking out of a bone, like this little bump here, that's typically a place for muscle attachment. Could be also an articulation, but it's often for a tendon to attach to a muscle. Some parts of bones are shallow. That's a depression. And that's also a place for attachment for muscle. It's also for protecting things. Like there's a depressed area inside of our skull. That's for protecting our brain. Could be for muscle attachment. Could be for what did I say? Protection or attachment. I know. Sorry. Last one. All of these terms just mean hole or space. If you have a hole in a bone, it's to let something through. You have holes in the back of your eye sockets to let a nerve through. You have holes in the base of your skull to let the spinal cord through. Like that's a big hole in the base of your skull. That's to let your spinal cord through. Holes are to let nerves or blood vessels through. Typically nerves or blood vessels. Those are the major features. I know there's a ton of words, a ton of terms that fit under each one. When we go over each bone, I'll point out each specific kind. But it'll take time to get used to all these terms. I encourage you to, if you haven't checked that discussion out, to look that up. Thanks for staying an extra minute. Don't worry about activity 4. I'll figure this out. Activity 3, if you haven't turned that in, please turn that in by the end of the day. Thank you.